Should have presented this earlier. We have 1, 2, 3, 4, 5 different geometric figures sliding down the incline. They all had MGH up here. That box is certainly going to get to the bottom first. There's some friction issues that in reality will make the order of these objects different, but let's take friction away. That box is going to get to the bottom first, because MGH equals only 1/2 mv squared for the box. These four objects, MGH up here has to equal 1/2 mv squared plus the rotational energy that each one of these are experiencing and that the box does not. So the box gets down at the bottom first. These four, you tell me, why is this the last one down? Why is this the first one down? Why are these two in the middle? Look at this. They all have the same mass. It doesn't say that, but they all have the same mass. Here, mr squared, I equals mr squared. All the mass is out here around the ring, around the outside. A lot of inertia, big resistance to rotational motion. And as you go down to the blue sphere, the moment of inertia decreases. Less resistance to motion, it's going to go down the hill pretty quick. Let's say I got a motor that has a flywheel in it that has a initial angular velocity of 20 radians per second.
That's time.
Okay. Jeez, look at all the bells. And then I increase its rotation to 40 radians per second. And I do that in 3 seconds.
Okay.
How am I going to find my angular acceleration?
One of the problems.
Which equation are we going to use?
Second.
Think it about in the linear world. If I gave you both velocities in t, what equation would you use to solve for acceleration?
The first one.
The first one, Vf equals Vi plus At. So what am I going to use here? Wf equals
Wi plus, no, shouldn't it be fish thing?
Alpha.
Look, you did it again. Alpha t. Does that make sense?
Yes.
So therefore, alpha's got to equal Wf minus Wi divided by?
T.
Therefore, what do I got? 40 minus 20 over?
3.
20 over 3.
It's like 6 point something.
What are the units?
Radians.
Radians?
Over seconds.
Over seconds.
Squared.
Where?
It's acceleration.
It's an acceleration. Does that make sense? Now the question is, how many, what's the angular displacement during this time? What's the angular displacement during these 3 seconds? How would we set it up?
It's 20.
Say it again?
Isn't it just 20?
I don't think so. How'd you get 20 from here?
Oh, yeah, no, I was doing 41.
I'm looking for the angular displacement. If I was asking for the displacement in the linear world, what equation would you use?
Vf squared.
Equals Vi squared plus 2AD, or what's the other one?
The D.
D equals
VI
T
plus 1/2
half plus 1/2 A.
Turn that into an angular equation. D equals VIT plus 1/2 AT squared
So
in the angular one. Theta equals
Wf
I
T plus half
alpha.
T squared.
So what's my angular displacement going to be? Give me some numbers.
20
20
times 3
3.
plus half
alpha.
What's alpha?
We got up to 6.3.
6.3.
and then
T squared.
3 squared.
3 times 3.
No.
Does that make sense?
Well,
And what are these units? So this is going to be 60.
Yeah, it's about right. The end problem is
It's
supposed to be 3 squared, not 3 to the 9. Not a big deal.
Thank
You
you.
don't want to confuse people watching
No,
the video.
no. Well, see, when I put those in there on purpose, so
It's
it's
squared.
squared. So this has got to be 60. I'm getting sloppy.
Plus
60 plus 1/2 of 3, or 1/2 of 6.
Like
3
3.
times 9. I'm just going to use rough numbers here. 27.
Yeah.
Agreed?
Which is 87.
So that gives me 87. What are the units? Make my day. What are the units of angular displacement?
Omega.
That's the symbol for angular displacement. What are the units? What are the units for linear displacement?
Meters.
Meters.
So it's radians.
Radians. Radians. So this flywheel, right, goes through 87 radians in 3 seconds, given this beginning and ending angular velocities. Does that make sense?
Yeah.
How would I change that to revolutions?
You would,
You just divide it by 260.
A 360 gives me degrees. I want revolutions. How many radians in a revolution?
360.
No, those are
pi.
degrees. Two pi. So if I got 87 revolutions and there's 2 pi radians, right?
Divide 2 pi.
So 1 rev over 2 pi radians. So 87 divided by 6.28 would give me the number of revolutions. Does that make sense?
Yeah.
So this has got to equal 87 over 2 pi revs.
Makes sense.
Do we see that?
Yeah. No.
Do we?
yeah.
Yeah.
Okay, so the critical thing here is that every linear equation has a matching rotational equation. Whenever you see velocity, you're going to put in
WF.
WF or omega if you're Greek. If you have an acceleration, you're going to put in
Alpha.
alpha. And if you have a displacement, you're going to put in
Theta.
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 And the absolute critical thing to remember is 2 pi radians is equal to how many revs?
1.
1 rev. And 1 rev is equal to how many degrees?
360.
360.
This is the critical thing. When in doubt, bounce back to this, and you'll be in pretty good shape. Okay?
Yeah.
So, as the inertia increases, what's going to happen to my angular acceleration?
Decrease.
It's going to decrease. And I can map every linear equation with a rotational equation. Just looking at those 3 different parameters. Okay?
Yep.
Questions? Okay. So, the last thing, what's a common angular velocity? What's a common, we see it every day.
RPM.
RPM. RPM stands for what?
Revolutions per minute.
Revolutions per minute. Is that MKS?
No.
So how am I going to change revolutions per minute into MKS? Let's say I got 40.
Seconds.
Let's say I got 40 RPMs, 40 revs per minute.
Okay.
How am I going to change that? What am I going to change it into for MKS?
Radians per second.
Radians per second. This is a velocity.
Yeah.
So what do I got to do first?
That's got to be 2 pi. You got to multiply 2 pi over 60.
We got 2 pi that's what it comes down to, but let's do it slower than that, Craig.
Okay.
We got 2 pi radians over 1 rev. And how many minutes in a second?
60.
1 minute, 60 seconds. The revolutions cancel. What else cancels?
Minutes.
Minutes. What am I left with?
2 pi.
Radians per
Seconds.
seconds. So to change, bottom line, to change RPMs to radians per second, what do you got to multiply it by?
2 pi over 60.
2 pi over 60 or pi over?
Pi over 30.
Does that make sense? Almost all problems start with RPMs. You got to get rid of it and get into radians per second. On the AP test, you're not going to have a lot of time to do this. It'd be nice to know, just divide the darn thing by pi over 30. Well, pi is 3.14. You could, a rough estimate would be multiply it by
Just about 10.
1 over 15. You're right, I'm wrong. 1 over 10.
Yeah.
0.1,
Yeah.
right? So if I give you 40 RPMs,
It's like
4
4.
radians per second.
Okay.
3 over 30, 1 over 10, 0.1. So that's a quick and dirty for a time test. All right, so we'll finish this up next time.
Makes sense.
Thank you, ladies and gentlemen.
15 minutes.
How much?
15 minutes.
Oh, yeah. Way too long.